All right, and then for part C and D, it says if the total area available for the gardens is 300, what are the dimensions for each garden? So basically, we have this equation already. Let's see, where can I do this? We have this equation already for the area, right? We found how the total amount of areas for the 12 gardens, but now they're saying the total area is equal to 300. So we're allowed to equal those together, but they want the specific dimensions. We have to find x. So we have to get x by itself, all right? So take the number in front first, divide by 12, simplify that to 25 equals x squared plus 4x plus 4. All right, remember, you're dealing with quadratics, you're factoring. So get rid of this 25. To get rid of it, you subtract it onto both sides. This turns into 0, and now you have a trinomial. Do not leave this. You can factor this. What two numbers make negative 21 that also add to 4? Okay, so 7 and negative 3. You can do the grouping. You can put them right in parentheses like I did here. Okay, but it's still equal to 0. So now you got to set both parentheses equal to 0. X plus 7 equals 0. Subtract 7 on both sides. X equals negative 7. X minus 3 equals 0. Add 3 to both sides. X equals 3 feet. We're finding the dimension of that original garden. Why are we rejecting a negative 7 feet? Because you can't have a negative 7 feet. That doesn't make sense. So usually with quadratics, you have those two solutions. But in these real world situations, you might have to reject one, right? A negative 7 feet does not make sense. So positive 3 will work. But that's not our answer. Okay, x is 3 feet. But if we go back up to our original problem, what was the width and the length? 2 plus x. So to get the original, you have to add 2 plus 3 to get the 5. And that's how I got 5 by 5 as the original area. Okay, so those are real world examples. For your homework, there's one real world example and 3 problems like this. So again, you're solving. So they should be equal to 0. Get x by itself. Add 9 to both sides. Now you have 3x squared equals 9. What do you do to both sides? Divide by 3. How do you undo an x squared equals 3? Take the square root. You're going to have 2 possible solutions, right? When you take the square root, the answer could be positive or negative, okay? Same thing here, all right? You can also do this as a difference of perfect squares, right? If it is a perfect square, these two. Sorry. Let me scroll down. Same thing here. Okay, divided by 2, square root. This thing hates me. What else we got? All right, isolate gets c squared by itself. So if we go to your homework for lesson 6, we did that. All right, so you have, right, you have a d plus 4 squared equals 5. You got to solve. You're solving for d. If it's something squared, right, take the square root of both sides, get d by itself. Here, what do you do first? Think of PEMDAS 2. Subtract the 6 first, and then you're solving for G. Check your work. When you plug into G, I want to see checking. I want to see verify your answer for these. I want you to verify. This is okay. When you verify, you're checking. When you check, you're plugging in. Horrible handwriting. Okay? Plug it back into the equation to check yourself. Number 7, you're missing the equation. I don't want to put the wrong one, so I can repost this. But Mischief is a toy poodle that completes her trainer in the agility course. Within the course, Mischief must leap through a hoop. Mischief's jump can be modeled by the equation x equals, and I'll put that in, where h is the height of the leap in feet and t is the time since the loop in seconds. At what values of t does Mischief start and end the jump? So this is going back to our classwork problem. So look at what I went over for classwork, and then I'm going to post this. You don't have that, so make sure that you see that, okay?